This podcast is about polar warming, and we shall look at several aspects of it because they're of so great importance for what's happening to the rest of the world. The temperature increase, the rate of temperature increase at both poles is now much more rapid than the global average, and there are dramatic effects resulting from this. According to some estimates, the land around the North Pole may be warming by as much as 4 times the global average. Now, in the Arctic, a major concern is the future of the Greenland ice cap. There are rapidly increasing areas of pooling water, and also the level of the ice cap has been shown to get lower during recent times. The melting ice cap, together with the effects of the rapid decline in Arctic sea ice, which is also a very important contributor to global warming, these generate feedback loops, which are illustrated in the figure that comes now. The feedback loops threaten to make ice loss ever accelerating, and they may actually force the processes to become irreversible.
And why is it so difficult to project future polar ice loss with more certainty?
It's mainly because the processes are non-linear, and not all of them are well understood. For example, only very recently have people begun to realise that the ice fronts that border onto the sea from the Greenland ice cap are losing ice and melting at a very much greater rate than previously thought. So models that have been developed are rarely accurate, and if they are reasonably accurate, they're very difficult to project into the future when there are feedback loops and non-linear effects of the kind that we've illustrated. In past geological eras, much of Greenland's ice melted when the Earth's temperature was only slightly warmer than today's, and there are plant remains frozen beneath 4,000 feet of ice in Greenland, showing that most of the Greenland ice sheet had melted about 1 million years ago in a climate not so different from today's. And so present commitments and trends suggest that human-caused global warming may indeed push the ice sheet past tipping points in the next few decades.
And is it really likely that future ice loss will be as severe in as these examples that you've given in the past?
It's by no means certain, but the present trends and the nearness to tipping points means that it cannot be excluded. We really cannot say it's not going to happen. Rapid Arctic warming has also triggered permafrost thaw that's now releasing carbon on the same scale as many large nations. Antarctica has been losing about 250 billion tonnes of ice annually in recent years, and research has shown that the rate has increased 6-fold since 1979. So this gives you a feel of how these processes are accelerating at both poles. Now, in the Antarctic, the main concern is the effects of a warming Southern Ocean on major coastal glaciers. There's an illustration of this in the figure. Most of the coastal ice is actually floating on the sea, so when it melts it will have little direct impact on sea level. But the coastal glaciers serve to hold back land-based glaciers, and once the coastal glaciers, which form a plug, once they're lost, then there is an accelerated seaward movement of the upstream glaciers on the land, and they tend to break up and carve into the sea, and that does lead to a rising sea level. So, in this way, West Antarctic ice shelves may in fact reach climate tipping points, and they may crumble into the sea with very significant impacts on sea level. Now, in this regard, a lot of interest has focused on the so-called Doomsday Glacier, the Thwaites Glacier in West Antarctica, on the West Antarctic Peninsula. It could, if it totally collapsed into the sea, raise sea level on its own by around 0.5 metre and destabilise glaciers further away from the coast. So there is a real danger here, and a huge amount of research invested in trying to understand how threatening the demise at some stage of the Thwaites Glacier is likely to be. Finally, there are recent recorded temperatures in East Antarctica, which is much less vulnerable to warming than the West Antarctic area. But even there are now signs that ice shelves are being lost, and the East Antarctic ice sheet may also be under threat in the future.